Hi everybody, this is the Algebra 2 video on section 1.2.2. It's a function investigation. We didn't do 1.2.1 because we actually have to create some things and we're not together. So we are just going to look at a function and we are going to investigate different parts. All right, so when I'm looking at my function, you guys are each going to have a function and it will be in a Google Doc. You will choose the function based on when you were born. And I get my own special one, which is f of x equals 1 over x minus 7. That's that one. So what you're going to do today when you investigate a function is you are going to investigate it in a number of ways. You are going to investigate the graph. And that's really the big thing we're going to do. We're going to also use a table. Okay, and then we might use the equation. So what we're going to do is we're going to come up with a graph, and then we're going to state some things about that graph using the vocabulary that you've learned about graphs. All right? And we're going to try to make things easier because we want to use our technology as well. Okay? So in order for me to get a graph, okay, I'm going to use my graphics calculator. So this is what I just did from yesterday. All right. So you're all going to have your own function, and if you want to find your function and kind of follow along with your function, you totally can, or you can watch this and do this for your function. So I'm going to take 1, and I need to divide it by x minus 7. So I'm going to use the division sign. And then I need the x minus 7 to be in the denominator, so I'm going to put parentheses around that in my calculator. So the parentheses are above the 8 and the 9. So we're going to have x minus 7. All right, I'm going to do a zoom 6 because all of your graphs you should be able to see if you have a standard graph. Ooh, look at that. Interesting. So it looks like I have 2 pieces to my graph, and there should be reasons for that. But if I trace this guy, because you can trace it, when I press trace, do you guys see my flashy box kind of moves? So I'm still getting points. So it looks like it's 2 pieces, and there'll be a reason for that in just a moment. And this guy just seems like it's getting closer and closer to a y of 0. And this, on this side, also looks like it's getting closer and closer to a y of 0. So what I need to do is I need to graph this, okay? So you guys are going to have a couple of different things here. You'll have, I will go between my graph and then this graph as well, just because this will be bigger than that. But you're going to do this on paper for your graph, and then you're also going to have your table on paper as well, all right? So let's start with our table. Okay, one thing that you'll notice, okay, remember f of x is the same thing as y. So I can use x or f of x here. It really doesn't matter to me. All right, so if I'm looking at the Google Doc and what I need to do on mine, I need to go from x's of -1 to 8. So -1, 0, 1, 2, 3, 4, 5, 6, 7, and 8. All right, so let's go to our table. Okay, we'll go from -1. Now, you guys do not need to write all the decimals down. You can just go to the nearest hundredth. So I'm going to go -1.3 or -0.13, my bad. At 0, I'm at -0.14. At 1, I should be at -0.17. At 2, I'm at -2. And I'll make some sense out of this. 3, I'm at -0.25. 4, I'm at -0.33, still at negatives. -0.5 at 5. Going down to 6, I'm at -1. 7, there's an error. Now, if there's an error, we call that an empty set. So this means that there is an error, there is no answer. And there's a reason for that in a moment. And then we're back at 1 for 8. And then you guys see that if I keep going down, it's going 1/2, and it's getting smaller and smaller and smaller. It looks like it's getting closer to 0. Now, if you actually did the math in here, this should totally make sense because, like for this guy right here, it'd be 1 over -1 minus 7, that's -8. This guy should make even more sense. 1 over 0 minus 7 is -7. All right, so if I look at 1 over -8, I get -0.125, which I rounded to that. All right? Now, the big thing here is what's happening here. There is no answer, okay? So let's think about putting 7 in here. What is f of 7? Wouldn't that be 1 over 0? Okay, can you divide by 0? No, you can't. If you think that this equals 0, checking it, wouldn't 0 times 0 have to be 1? That doesn't work. If you thought that this was 1, wouldn't 1 times 0 have to be 1? It doesn't. So what we say is that's the empty set. There is no answer here. So a big thing here is x cannot be equal to 7 because 7 makes the denominator 0. And you can't divide by 0. All right? So I'm going to go back between, I'm going to do this guy first, okay? And you guys are going to have a graph. Hopefully you have some kind of graph paper that you can do that on your homework. All right? But I'm going to shift this off just a little bit, and I can see my table. I don't know if you guys can see my table. There you go. That's good enough. I think you'll be able to see everything. Okay, -1. So I don't really like a lot of these points, but I know what it looks like. Doesn't it have to look like that? 2 pieces, right? Okay. So let's see here. There's nothing at 7. So if I go at an x of 7, 1, 2, 3, 4, 5, 6, 7, that's right there. There is nothing there. So there should be, I'm going to put this yellow line all the way down because there should be no points on that because x can never be 7. Now, if I look at some other points on this, I'm going to go around this line here. Like 5, I'm at -1/2. 1, 2, 3, 4, 5. I'm down about 1/2. At 6, I'm at -1. We'll get to the rest of them in just a bit, but these are the ones I got. I mean, if you look at 4, it's like -0.3. It's getting closer and closer to 0. So this is what that looks like. And it should not cross that yellow line, and it should not cross the y-axis or the x-axis. Now, if I'm looking at 8 was 1. Okay, and then what I might want to do is look at my graph. Doesn't it look like it's going up here and then it's getting closer to the x-axis? So we're going to have something like this, and if you have to, this was like 9 1/2, and this would be 1/3. All right, so that's what it looks like, and we need to have arrows on the ends. All right, I'm going to go between this and this, and when I need a smaller picture, I'll use this guy, okay? But I want to get to some new vocabulary, okay? Because we have a table, we have a graph, and then we have an equation as well. So this is going to be enough to get through our function investigation. This yellow line here, you guys, is what we call an asymptote. So an asymptote. So it's a asymptote. A-S-Y-M-P-T-O-T. An asymptote. This is a line that a curve approaches, because isn't this curve approaching? Now, vertical lines it won't pass through, but sometimes if we have horizontal asymptotes, it will pass through. So what I like to say to cover the whole asymptote thing is to say an asymptote is a line that a curve approaches and sometimes passes through. All right. All right. So if I'm looking at this guy right here, it's a vertical asymptote. That's a line. This line is in the form x equals 7. That's my vertical asymptote. So a vertical asymptote, this is going to be a vertical line that's in the form x equals, that a curve does not pass through, because it never will, because those are the spots where the denominator is 0, and the horizontal asymptote, sometimes it passes through. We're not going to get to horizontal asymptotes for quite a while. And this is a horizontal line, a curve sometimes passes through. All right, and if you have to press pause, that's my big vocabulary, you guys. Okay, so usually if I was in class, I'd have a big board that we were working on. I don't have that much room, so what I'm going to do is usually I would use this, and I'll flash between that and that, but I'm going to use this for the most part. Okay, so here is what we are going to do today. Okay, today what you're going to do is you are going to do a function investigation, and I'll use my calculator, and I can always go back to my written graph as well. Okay, and I probably could lift this thing up a little bit. We're going to go through all of the vocabulary that you guys have had already, okay? And then we're going to use that to write some statements, and then we're going to come up with some justifications, okay? So I have a lot of different vocabulary that we go through, and I will go through every single one with you, and I will write a statement. So a statement just tells me what's happening on a graph. It tells me something about a graph. The justification will justify that statement. Sorry, I hit my camera on that one. It's going to justify the statement graphically. So by the graph, by the table, or the equation. Now, generally what we do is graphically and by the table for now, because we don't have that much algebra skills, many algebra skills to get through everything, but I will make one statement about this that I will use the equation for. All right? So I have a bunch of topics for you guys to make your statements on, okay? I think I'm going to go through most of them, and then I'll get through the end of them in just a bit, okay? So if I ask you guys for a statement, one thing that they make statements on, I'll make a list on the left here. How does that sound? Are x-intercepts and y-intercepts. Okay? So what I'm going to do is I'm going to flash between here, and then we're going to make some statements. So let's start with the x-intercept. I'm going to look at here. All right. So if I'm looking at the x-intercept, you guys, does it look like my x can ever be equal to, that my y will ever be equal to 0? So looking at that, I'm not sure. So it doesn't look like it can be, because if I make my y equal to 0, I'd have to come up with some kind of x. Okay, so if I make my y equal 0, I'd have 0 equals, I'm just writing this on here, 1 over x minus 7. Let's see if we have an x-intercept. And then we'll make sense of that x-intercept right here. 1 times 1 is 1. That equals, all right, let's see here. I'm going to have 0 times, because I'm using cross products. If you don't know me that well, but I'm telling you, I love cross products. 1 times 1 is 1. 0 times x minus 7, that's 0. Can 1 ever be equal to 0? No. There are no x-intercepts. That is by the equation. So here is my first statement. My first statement. The function. My function is f of x equals 1 over x minus 7 does not have any x-intercepts. Okay, that is my first thing. Does not. So mine does not have any x-intercepts. Someday you might have some x-intercepts. Okay, justification number 1. This one will do all 3 justifications. Justification number 1, let's go by the graph. Everybody loves graphs. Does it look like the graph's going to intersect the x-axis? No. Justification number 1, the graph does not contain any points on the x-axis. Okay, that's my first one. I can say, here it is, that's my graph, not seeing any points on the x-axis. Justification number 2. All right, let's look at the table. So this is the table I have. What about the table says that I don't have any x-intercepts? Well, if I look at my y's, okay, my y, I never get, because didn't I have to make my y 0? I don't get a y of 0. Okay, so since there are no y's that are 0, there are no x-intercepts. Justification number 2. The table does not contain a point where the y coordinate is 0. Yes, guys, these are all full sentences. Subject, predicate. Justification number 2, or number 3. the equation. Okay, so I actually put the math right up here. When I put 0 in for the y, I could not get an x. So the equation cannot be solved for a y of 0. Now, I'm going to tell you guys right now, this justification by the equation, we're only going to be able to do this sometimes, okay? Because we don't really have a lot of the math skills to get through all of them. All right? Okay, let's go to another statement. Now, I'm not going to do the y-intercept just because, you guys, we did the x-intercept. I'm going to try to make this so that you guys have to actually come up with some justifications, but I will make a statement about this one. So I'll make the statement. I'm not going to do justification. So if I'm looking at the y-intercept, would it make sense the easiest place for me to find the y-intercept would be where my x is 0? Right there. So I'm going to say my y-intercept is at the point 0, negative 1/7. So that's my statement. The function f of x equals 1 over x minus 7 has a y-intercept of 0, negative 1/7. And then you could go through some justifications on that. I want you guys to figure out your justifications that you're going to make, okay? Because I want to be here forever because this is already long enough. All right, next statement. Let's do a statement about, so other things we can do would be domain and range. So I'm going to do the statements and the justifications for the domain. I'll tell you right now, domain goes a lot with some other things like the x-intercept. Sometimes it has something to do with it. So here we go. Okay, the domain of, so this is my statement, sorry. Getting sloppy. The domain of f of x equals 1 over x minus 7 is. All right, I can describe this in some way if I want to, but let's think about it. Domain is our x's, right, you guys? This is the table. Could I have every x in the world? No, it could not be 7, okay? So the domain of this function is any number, but x cannot be equal to 7. That's my statement. All right, justification number 1. Okay, and the first one we're going to say is by the graph. Okay, so if I look at the graph, does it make sense that when x is 7, there are no points? So by the graph, when x equals 7, there are no y coordinates. And I'm going to put in parentheses, there's no points. All right, so there we go. Justification number 2. All right, by the table. Okay, so by the table, I'll just go to this table here. By the table, lots of kids say there's an error at 7. I'm just going to say that by the table, the function is undefined at x equals 7. And I'm going to say there's no y. All right? And then, let me just add this one down to the bottom here, justification number 3. By the equation. Okay? By the equation, any x, we can put any number in for x here, except the number 7 because it makes the denominator 0. So by the equation, we can put any number but x, or but 7 into the equation because 7 makes the denominator 0. Okay. So that's my statement. Those are my statements and my justification. Now, for my range, range is a little tricky, you guys. So I'll make a statement about the range as well. I'll actually use the top of this. So my statement on range, the range of f of x equals 1 over x minus 7. I won't write too many more sentences. Now, we haven't really talked about what your y's can't be. It looks like they go down forever and up. I'm going to tell you right now, any of your functions, there are no y's of 0. Okay, so the range of f of x is any y except 0. Okay, and you can look at that by the table, because on the table it looks like we're getting closer to 0, but we don't have any points at 0. And then also in the graph, it looks like it doesn't hit any y-intercept, okay? Because that would be, I'm sorry, any y, it hits all the y's, I'm sorry, except for a y of 0, which that goes somewhat with the y-intercept, all right? So next statement. This is the last statement I'm going to write some justifications with. The rest of them you can choose if you want to do. Asymptote. You can make statements about asymptotes, okay? So I'm going to put this off to the side here. Okay, the function. So this is my statement. The function f of x equals 1 over x minus 7 has a vertical asymptote of x equals, we said 7, correct? Justification number 1 will be by the graph. Okay, so by the graph, justification number 1, by the graph, there are no points when x equals 7. So by the graph, there are no points for an x of 7. Justification number 2, by the table. Okay, so by the table, I'll just use this table. By the table, when x equals 7, there is an error, or it's undefined. And I can actually do a third justification on this. Third justification I'm going to do is by the equation. Okay, so by the equation here, we kind of had this right here. When I put 7 in for x, didn't I get an undefined? Okay, so by the equation, when x equals 7, it is undefined. Because 7 makes the denominator 0. And you cannot divide by 0. There. So I'm getting kind of sloppy there, but it's a lot of writing. Okay? So that is those. So that's your new vocabulary. Okay, and I will put this in, now that I'm thinking about this, I will put this in the directions for this lesson. You don't have to write everything down that I'm doing, but you do need to have the list of statements, the ones we can make statements of, and then you also need to have the vocabulary word asymptote. All right, now those are the big ones. Generally what you'll be asked to do is maybe do a couple of them, and then you need justifications. Statement is telling me what it is. Justify is to say, I can justify it by the graph, I can justify it by the table, I can justify it by the equation. For now, I'm just going to have you guys do just 2 justifications. I'm assuming you're going to do one by the graph and one by the table, because the equation can be kind of interesting. All right, so at this point, we'd end class by saying, okay, what else could I write statements on? What other parts of graphs did I have? I could write about a maximum point. I could write about the minimum point, if there is one. I could talk about a starting point. I could talk about a starting and ending point. Sorry, I'm getting into that. And then in the past, I've had some kids who talk about, so I have those, I talk about symmetry, if it's symmetric. So again, things you can make statements on. You can talk about the x-intercept and the y-intercept. Those usually go together. Domain and range, those usually go together. Asymptotes, most of the time we're going to do vertical here because that's what we talk about. A maximum point, a minimum point, the starting point and the ending point, and then symmetry. We've talked about all those with graphs that we've had. So on this one, I'll kind of go through, do I have a maximum point? I would say for my statement, this function does not have a maximum point because it goes up forever. Okay? Or the statement would be, there is no maximum point. Justification on the graph, it goes up forever. I would say for a minimum point statement, this function does not have a minimum point for the justification on the graph because it goes down forever. And then you could also do that in the table. Starting point, I'd say this function does not have a starting point. How come? Because it seems like it goes to the right and left forever. And I'd say it doesn't have a starting or an ending point for the same reasons. And then symmetry. Symmetry is quite interesting because it actually does have symmetry. If I drew a line like this and I flipped it over, it does have symmetry over a line. It has reflective symmetry over a line. So I could say that this function has reflective symmetry over a line, but when we get to even and odd functions, guys, it's going to not have that kind of fun symmetry. It's an interesting kind of symmetry. So I know I talked a lot about this. Your assignment is to do this for the function that defines your birth, and that is attached to the Google Doc. What I would like you guys to do is to either type these things out if you want to for your statements and justifications, but you need to have statements and justifications. You are going to have, I'm going to have you guys do 5 statements. I should write that down because I made. So I'm going to have you 5 statements, and on those 5, I want you to have 2 of them with justifications. And each 2 of those need to have 2 justifications, okay? So for instance, when I'm looking at what I did, okay, this is everything I did, right? Yep. So I could say, okay, here's 1 statement and 1 justification. Here we go, we'll start here. So this would be 1 statement with justification 1 and 2. That would be good for my assignment. And then another statement right here with 2 justifications, that would be good, and that would meet my statement and justification. So there's these 2 statements with 2 justifications, and then I have to come up with 3 more statements, no justifications. Hopefully that makes sense. And that will be due on, I believe, Wednesday or Thursday. I got to get my mind back in order. All right? So you'll have your statements, your justifications for 2 of them, then you're going to have 3 more that just are the statements. I also will want to see your table and a graph, okay? And that table and graph can be pictures like this, or they can be pictures from your graphics calculator where it is this, and you could also do a snapshot of that. All right, good luck.